But you and I have done, we've crossed this path before about high dynamic range cameras, and I was
Hmm.
super impressed by some of the stuff you showed me. Can you tell us a little bit more about that? What's happening there?
Yeah, what do you think about the data center impact?
All right, so let's explore some other areas. We talked a little about driving with sensor fusion and so on. Do you see them going into other industries? I mean, I'm working in construction, for example. I see there's opportunities there. What are you seeing from your perspective?
I mean, I have a Tesla and I turn it on to full self-driving to go, 100, 200 miles on the freeway.
Mm.
And for a freeway environment, and even during, a small town, it does really well.
The final question, which is
Okay.
AI, is it hype or help?
It's absolutely.
G'day and welcome to the show. I'm your host, Pete Cooper, and our topic is AI, hype or help. Today's guest is Chris Silsby. Now, Chris is a lifetime professional in image science, image sensors, cameras, and now AI and how it relates to that topic. Now, he and I share that very common background and interest in vision systems and cameras. So this is going to be a very interesting discussion. I hope you enjoy it, and let's get into it. G'day,
Hi,
Chris.
hello.
Welcome.
Thank you for having me on.
Thank you. I've been chasing you, maybe not actively chasing you, but thinking about having you on the show for a while. And
Okay.
I know we're going to get into some really interesting stuff because there's a great crossover. Um, so you and I go back to, I think it was 98 when we first met. I was with Nokia and you were with a company called Agilent.
Hmm.
And we started working on cameras way back then. Do you remember what people used to say about putting cameras in phones way back then?
It depends on who you ask, but I
Mhm.
mean, they had uh, conferences where they presented that older populations said there's no way cameras will replace people's primary camera
Mm-hmm.
and or cameras and cell phones would replace a primary camera. But the
Mm-hmm.
younger generation, the 18 to 24-year-olds, a large percentage of them thought, someday I can see that my primary camera will be in my phone.
Mm.
And sure enough, as a as that younger generation grew older, and the cameras improved. Now that we see that everybody's almost everyone's using their
Exactly.
cell phone as a primary camera.
Yeah,
Yeah,
I just remember this soundbite and I quote to everyone, and that is that people used to say, "Why would I need a camera in my phone?"
yeah, exactly. I remember when we first did a study that everybody talked about what they would use a camera for, and it turns out that just a VGA image would be enough for 80% of the cases of what people would use it for. Like, hey, honey, is this what I'm supposed to buy at the store?
Mm-hmm.
Or
Mm-hmm.
um, just trying to capture a memory.
Yeah.
So yeah,
So let's get into that. But let's first of all introduce you, Chris. Tell us a little bit about your background and what you're doing now.
yeah, I started at HP in the integrated circuit business division. So I
Mm.
spent a lot of time learning semiconductor processes, and I worked in a variety of roles there as a process development manager, as a product engineer, as a yield manager, um, and photolithography engineer,
Mm-hmm.
and then moved to the image sensor design role in a similar time frame when we met
Mm.
at the end of 1999, 2000.
Mm.
And that's what I've been doing for the last 25 years.
Mm-hmm.
And recently moved to an applications development role, which is more of a systems level, automotive systems level role,
Mm-hmm.
looking at how to integrate image sensors with the automotive system.
Yeah. So if the audience doesn't know what the image sensor part is, every digital camera now has an image sensor, which is the silicon that sits behind the lens,
Yeah.
does all the kind of the work of converting the light photons into electrical signals, right?
Hmm.
Yeah. And so have you always been in that area of the world? You're in Oregon, right? Have you always been there or did you move around a bit?
Yeah. Well, I moved to Colorado for a couple of years just because HP was
Mm.
um, had a fab start up there, and we were transferring some processes
Mm-hmm.
to Colorado and then overseas. And so a little adventure with the family to Colorado, and then I moved back and currently in Oregon.
Nice. Nice part of the world, that. the way you live. I came up to
Yeah,
see you a couple of times, and
it's beautiful.
it's a little wet, I guess.
Yeah.
But oh, that's really nice.
Yeah, yeah.
Yeah. So, what are you doing now? I mean, what's interesting now with what you're doing? I mean, we've seen. I guess let's educate everyone about what's happened. We started off with together with these tiny little sensors, right?
Yeah, yeah.
VGA, as you said,
hmm
which is only 360,000 pixels.
hmm
And I can remember also these conversations that VGA would be enough. And also it was, I guess we constrained ourselves by thinking, well, you got to fit it into a small phone. And back then, I mean, phones were small.
Yeah, yeah.
They were like getting
When
smaller
we
and
and
smaller.
we still sell, I'm focused on camera for automobiles, so cameras in automobiles, whether it's a backup camera or a forward-facing camera or a side camera. That's been our focus. It's been my focus for the last 15 years, really.
Mm,
And we still sell VGA cameras, mostly for backup cameras, right? But for a lot of people, a VGA camera, you know, is 640 by 480 um, columns and rows is enough to see what's behind you and avoid running over somebody. Um, but the latest generation is 8 million pixels, right? And the 8 million pixel 8 meg cameras, which is like a 4K resolution, right?
mm,
4,000 columns.
mm,
Those 4K cameras is pretty typical now in
mm,
the highest end cars
mm,
and for forward facing, and in some cases even around the car.
mm.
Um, Cars have maybe 10 to 15 cameras now, um,
Wow. That
and
many.
eight meg is usually a forward facing. There's usually 1 to 3 cameras of forward facing,
Mm,
and then it's either 8 meg or 3 meg around the rest of the car,
mm,
um, capturing the environment. And in some cases, it's just a surround view function where people want to see what's around the car when they're parking or um, and when they're uh, sort of looking to move the car.
mm.
But in other cases, we have customers that are actually using all those cameras to make decisions about whether to change lanes and or whether to move the car out of the way if there's a threat event. So
Mm, mm.
um, it's there's a lot of processing that's going on now in the more recent cars.
Yeah, I think we're all familiar, I think, with the backup camera. I have one of those in both my cars, but I don't have any other cameras other than that. Um,
hmm
and then I guess the Tesla example is probably the most notoriety, has the most notoriety in the sense that there's been a march towards full self-driving,
hmm
which hasn't necessarily gone to the schedule and the timeline. And my perception there is that it's very, very hard to make the system as reliable as and as perfect as we expect it to be. And that's not that we're trying to be as good as humans. We're actually we're trying to make the hardware significantly better than what humans can do. And that, to me, is the big challenge there.
Yeah, I
I
think
think.
the better than humans is is possible, right? Because humans tend to focus have in a narrow view and just right in front of them. Even our own visual system, your brain is mostly processing the center field of view of what you're looking at,
Hmm,
and you have to move your head around to really gather the rest of the information. Where car has 10, 15 cameras and it's all feeding into an ECU that can process all that information at the same time. So its potential is there, right? To be better than humans for making better decisions, not turning and changing lanes when someone's trying to cross the road and running
hmm,
over somebody, or
hmm,
not pulling out when there's a car coming fast,
hmm,
and maybe running a stoplight, but you don't see it. So I think the
hmm.
potential is definitely there. Um, and uh, but like you said, it's those corner case conditions. It's the understanding intent and where other cars are moving,
Hmm.
what's going on in an environment. If it hasn't been something that it's been trained before, and
Right.
it has to come up with some its own causal reasoning, for what's going
mm,
to happen next, and
mm.
how does um, these different elements that have come into the scene, how are they going to behave? If it hasn't been trained, then it has a difficulty, deciding what to
Yeah.
do. And
There was a case with the
yeah.
Tesla that went under the truck,
Uh-huh.
and completely, you know,
Hmm.
decapitated the guy. It found out that he was not paying attention and he was relying on it
Hmm.
completely. And I think this goes back a few years. So obviously they fixed that problem, but it was the fact that the truck was white, and it kind of blended with the sky a little bit, and it was a new edge case that the camera system couldn't have detected. And I wonder if
Hmm.
that's a sort of a sign of a fundamental flaw with vision systems, is that if they don't know that there's something there, they assume nothing's there, right? And that's perhaps not the most
It could be,
safe
yeah.
thing.
And those older systems, the older cameras, I mean, that camera is now 15 years old, right? That had those issues, but
Mm.
also radar was involved, and
Mm.
the radar was imaging under the car, under the truck.
Oh, okay.
And
Mm.
so
Mm.
reliance on two different systems, radar and cameras, and the fusion of that information um, is also important for making decisions. And um, I, I I think at the time Tesla went away from radar temporarily,
Mm.
and just used cameras. And
Then they
then
came
I
back,
think
yeah.
now more recently they've added radar back in,
Mm.
and have improved the fusion decision making.
Mm.
But those corner case conditions, they're not so much limited by the sensors anymore, right? I mean, the latest sensors are um, significantly higher dynamic range,
Mm.
and
Mm.
significantly able to avoid
Yeah, yeah.
saturation, even in
Mm.
high bright scenes.
So in that dynamic range thing, that's the cases where you have like the sun,
Yeah, yeah.
in the
Or a
scene, and
white
there's
truck in the sun. Yeah.
yeah, and there's a dark corner over here. Like with a human, you'll look away from the sun and you'll look to the
Hmm.
dark corner. Your eyes will adjust and you'll focus in that area, or what
Hmm.
naturally turn your head away. But a camera can't turn its head, it can't turn away,
Right.
so it has to deal with the whole scene,
Exactly. Yeah.
and it doesn't see things that are in the dark because it's been
Hmm.
blinded. But you and I have done, we've crossed this path before about high dynamic range cameras, and I was
Hmm.
super impressed by some of the stuff you showed me. Can you tell us a little bit more about that? What's happening there?
Yeah. I mean, we're talking about cameras now that historically a digital camera could only hold maybe 100,000 electrons. Even the movie cameras that were used to make movies and films, they had big
Mm,
pixels and maybe hold 100,000 electrons.
mm-hmm,
The cameras now that we're shipping, um, and just announced, for example, an 8 meg camera that can capture over 10 million electrons in every pixel.
wow.
And if you can capture 10 million electrons in every pixel with the read noise less than an electron, right? It's 0.56 electrons read noise. We're talking about over 130 dB, over 21 stops of photography in every pixel.
Mm-hmm,
It's extremely powerful to capture everything that's needed to avoid making the wrong decision. And at that point, now your challenges are just teaching the system how to get past the just what it's trained for, right? How
mm,
do you teach the system to be more than just a child that's experiencing everything for the first time? How do you
mm,
set up the next layers of reasoning and intuition about
mm,
what's the right thing to do, right?
mm,
And
mm,
that is kind of the limitation, I think, of current systems, is that they're mostly based on training. And I know that the neural network training, a lot of the companies are adding on some structured um,
mm,
decision making on top of the neural network to
mm,
kind of give it some guard band and some constraints, and um, because you don't want the AI system to either hallucinate or make some intuition assumptions that based on the structure that you might learn as a
Mm,
human
mm,
going through life.
right.
And I think we underestimate just the huge amount of contextual we gather as we
Yeah, I think that I
yeah.
want to pick up on that because I was at a conference only a couple of weeks ago. This is in construction. I'll talk a little bit about that. And one of the professors from one of the universities said he doesn't believe in that the path we're on with just more and more large language models is the path to artificial intelligence. He said that that's a pattern
Mm,
recognition machine, but it has no
hmm
bearing in the real world, the
hmm
physics of the real world. He says what we
mm,
need is something else. He doesn't know what that is that
hmm
can interpret the real world, like a physics engine or something
hmm
like that. He didn't even use that term. I just made that up. That kind of incorporates itself into the AI that builds up the logic. So you can't make, completely irrational judgments
yeah.
about what's
Exactly.
actually
Yeah. Yeah.
there. And
hmm
that he said that's the path forward, but he doesn't know how that or how that's going to work out. And is that even really AI? Is it something else? I mean, you and I have been trained in science, and
hmm
it's deterministic. It's algorithmic. It's created on mathematics, and the mathematics has a result which is black and white.
hmm
And AI doesn't work that way. But the hybrid of the two is something that we as engineers, I guess we have our pattern recognition, we deal with people, we have all that neural network kind of stuff, but then we also be able to bring in the real world physics and the maths. And maybe that's maybe that's the path forward for, the self-driving too. You can't hallucinate something that can't possibly exist. There couldn't be an elephant flying through the sky.
Right. Right. Yeah. And
Yeah.
and there's there's interesting results that are happening as mathematicians. I just read recently that a bunch of mathematicians converged at Berkeley in order to study whether AI could solve some of the most difficult mathematical questions and mathematical solutions. And they were challenging the AI system that they were working on, and it was also learning as they were going.
Mm,
And after the end of this week of challenging AI and the system getting better and better, they came away, with the most of the people that were interviewed with sort of a profound new view of where things are headed. Right, it's not quite there yet, but they see the potential for these AI computers to have a significant role in mathematical theoretical solutions
mm,
and sort of breaking new ground. And
mm,
this is just an example of one type of computer that's focused for a very specific type of use, and they're these AI tools are trained based on patterns and mathematical rules, etc. Um, but in general, like you said, I think it's these layers of expertise on top of each other
mm,
that end up converting what looks like a new 1-year-old child that's looking around and trying to experience the environment and
mm,
crawling and you
mm,
know putting stuff in its mouth and
mm, mm,
is
mm,
it seems like these AI tools are they're really good at what they're trained to do, but there's still some corner case um,
mm,
contextual learning that we still need
mm,
to get added to these systems to
mm.
be fully not only safe and but for a wide range of conditions, but to be able to handle new things that happen. Right,
Yeah,
some new corner case condition that it hasn't ever seen before or been
right.
trained how to
Yeah,
deal with. Right.
yeah, exactly. So you mentioned that, we t touched on the whole thing about Tesla moving out of radar and back into radar. And I believe one of the changes is they changed the to millimeter wave, in other words, high frequency radar, which meant that it was more granular and more able to do things. And so it's back to the whole idea of sensor fusion, which is taking cameras and other things. And from the
Mm-hmm.
work that I've done in the field, I've noticed that when it's safety critical systems, they tend to have sensor fusion, like um, forklifts running around warehouses. They tend to have some lidar. When I was in Texas at this show, those Waymo cars, they had
Yeah,
cameras,
yeah.
but they also had those lidar systems. So,
Hmm.
do you think we still need to have sensor fusion, or do you think there's a near-term future for just cameras?
So the nice thing about LiDAR is that it gives you a depth result for every pixel.
Mm, mm,
And if you think about what decision making you have to make and what analysis of the scene that you're going to process, having depth immediately um, and accurately simplifies the decision making, right?
mm,
Because you already know where an object is and how far away it is, and so there's some simplification. Um,
mm, mm,
Tesla's presented an example in some of their YouTube updates or some of their conferences that they get depth because from parallelism
mm,
with two different cameras.
mm.
They get a depth information. The AI system itself will tell them this how far an object is um, because of the parallax. I mean, not
Yep,
parallelism, but parallax.
yep.
And so the that's more processing needed to get the same information,
Mm,
but it's still possible. You know what I mean?
mm, mm,
So the question is, how much easier is it for Waymo with several, maybe 3 or 4 lidar uh, sensors around the car, all getting depth information? It's likely more simple for them to make decisions about that are that are every frame that they get this information accurate as far as where things are, right?
mm, mm.
Whereas it takes some more latency and processing power to get some reference from the parallax. So
Okay.
I think it helps Waymo with to make faster decisions, and some of the processing is probably easier. Does
So
that
the
make
way I
sense?
was, you take it to a different direction. I was going to go in the direction of, well, if you've got the lidar information
Hmm.
and it sees something, like there's definitely an
Yeah,
object there, you can override the whole system and say, well, look, if you see something I'm going to run into, apply the
yeah,
brakes, no matter
yeah,
what the
yeah,
vision system says.
yeah, exactly. And and I think from parallax you can get the same information.
Right,
Um,
right.
I mean, you look at a shark, a hammerhead shark, that's got the sensors. They've
Yeah.
done tests, and it
Mm,
can see a quarter, on the surface of the
mm,
floor, at
mm,
100 meters or 50 meters or something like that, right?
mm,
So it's their sensors from echolocation are extremely accurate because of the parallax, and
mm,
so I
mm,
think the capability is there, but that's taking processing power from an overall box unit for 30 to 50 watts or whatever that's available in the system to do the processing. You're taking up processing power to get that information. Um,
interesting.
and
So,
I don't know that someone's done a lot of analysis of how much of that is of the total processing power, how much is that impacting the final system.
mm.
I don't really know that, but it is a little bit easier if you already have depth.
Yeah. So, I mean, I think about parallax in terms of, humans and the eyes, right?
Hmm.
They're a few
Hmm.
inches apart. And it's
Yeah,
very good at arm's length, right? If you want to reach out, you're a monkey, you want to reach out and
yeah,
grab the
yeah.
branch, it's really good at that. But as soon as it gets to sort of 30 or 40 meters away,
Hmm.
it's very hard to gauge that distance. Now, with a car, you can go a little wider because of the width of the car. But at some point, you're not going to get the resolution you need. And of course, cars go so much faster.
Hmm.
But maybe there's enough trade-off with the width and then the depth to get that to work.
Yeah, and the Tesla system is very good. Um, I think now that we have cameras that don't saturate, in various scenes, we're driving into the sun and with trees with or dark regions in a tunnel. They're so good now that I think a camera system is is very good and can be trained for those corner case conditions. I think
Mm,
the next level of what do you do with something you haven't seen before. I think both Waymo and Tesla have to deal with that.
Mm.
And um, we're going to hear about corner case conditions for both of those car systems and
All
both
right.
those companies as we move forward.
Yeah.
Um, I think one thing that has really resonated is that, and initially people thought in the industry, well, we're replacing something that's really not very good. There's 35,000 people die in the United States every year from car accidents, and so people are going to be happy if we can reduce that to 20,000 or 15,000 with cars, right? And that's not really the expectation, right? The expectation is that it's like an airplane, and that it's any accident has to get investigated, and these car systems are expected to be 1,000 times better than a human. And I think the expectation is that there's less than, instead of 35,000, if everybody was driving autonomous cars, the expectation is there's less than 10, in
Right.
that's the United States from these autonomous cars, because now it's a corporation killing your family or killing someone that
Right.
not a person, right? Which is fallible, and it's possible that we all make mistakes, right? But
Mm.
the
Yeah.
expectations are still really high, so that's kind of surprised people a little bit, I think.
Yeah.
um,
I would say it's almost the legal side of things, which is a bigger problem than the technology.
yeah,
The Who do
yeah.
you blame? Like you can't. Okay, that AI instance which was on there did the wrong thing. Let's delete
Hmm.
that
Yeah.
instance. Who cares?
Mm-hmm.
That instance doesn't care because it doesn't have a consciousness. But a human being, if they make a mistake, they can go to prison, and there's a lot of
Yeah.
consequences. And there's this kind of, I guess, this equity that we have in our society that if you do something wrong, you have to pay, the consequences of that. But
Hmm.
AI doesn't have any consequences, so it has to go up to the corporation, and then the
Hmm.
corporation has to bear the liability.
Hmm.
Um, and that's a faceless thing, there's no person to blame. And I think it's a challenge for us to, maybe this is one of the very first areas where we're starting to see AI replacing or taking society to a new level. Like if we go back to the jungle, I was in my monkey troop. If I didn't like the guys over there, we all gang up. I mean, they're in trouble, right?
Hmm.
That one monkey's in trouble. That was very basic, social fabric. Now we're so abstract from that. I mean, we were global company, global. We're, I know thousands and thousands of people. I can't possibly operate in that way. Now we've got AI again, throwing a whole new challenge. I don't know the way forward, honestly. Do you think there's a future for self-driving cars? I guess that's the question, right?
Right. Well, um, the the capability is there, to uh, grow and learn to be capable, um, of significant improvement over the number of deaths that we are seeing in the United States right now, right?
Yeah.
So I do think that if everyone was driving the most advanced car, like a Waymo car, right?
Right.
If everyone was driving behind the wheel, but letting that system drive, and it was only there for occasional, hey, something's going on, can you take over? That the number of deaths in the United States wouldn't be 35,000, right? It would be less. It would be
Mm.
significantly lower.
Yeah. Yeah.
So
Yeah.
I do believe that they're better than humans with expensive systems that are out there.
Mm.
And Waymo really isn't, I don't think, targeting trying to put all these expensive systems on every car. I think they're really targeting the rideshare market. If you've seen, they have rideshare in San Francisco, and hundreds of people are using this rideshare. Thousands, people are using this rideshare regularly. I just rode in one a couple weeks ago, um, and it's really interesting, having no one in the driver's seat,
Mm.
and using an app to pick you up and drop you off at a certain location, um, and it's pretty amazing,
Mm.
what it can do.
Yeah.
But they can afford the significant number of sensors and the significant sensing elements, because it's running 24 hours a day. It's a
Mm.
um, rideshare application. It's not like somebody has to buy
Right,
it
so you
and
can invest in the capital to get a
yeah,
return on it.
right,
Yeah.
right.
I see this, the way I kind of frame this is I say, well, look, I don't think AI at the moment, full self-driving, is as good as my best F1 driver, Formula One driver,
Mm-hmm.
on a good day, in good conditions when he's just on point,
Oh, for sure. Yeah, yeah.
versus somebody who's maybe elderly, impaired with alcohol, late at night, in poor
Mm-hmm.
conditions.
Mm-hmm.
AI is definitely better than that, but it's not as
Yeah,
good as that, right?
right.
And maybe that's the easy in, right? And you kind of pointed to it, that the ride share, where I know I'm not really shouldn't be driving. I don't feel that I'm capable of driving for whatever
Mm-hmm.
reason. I can choose to take a self-driving vehicle, right?
Mm-hmm.
That is a safer option than me driving home. Yeah, that's an
Yeah,
easy in, I
definitely. And
think.
yeah. Um, and the typical um, human driver has an attention span and an emotional level up and down, um, and distractions. There's so many different things that contribute to accidents besides the chemical. Large percentage of accidents are due to chemical related. So
Mm,
the AI can help those systems. There's a lot of stuff that doesn't get reported, right? I was driving on a 5-lane highway, and there was a Tesla in the fast lane up ahead of me, and lots of cars filling all the lanes. And this car saw an opening, and he was weaving in and out of traffic, and he saw an opening from the right side to get all the way across diagonally to the fast lane, and it looked he was gonna hit the Tesla. It was in the fast lane already, right?
mm,
And had an opening in front of it. And so he's coming at a 45-degree angle behind. The Tesla moves over to the side of the road on the shoulder, and the car takes its place and then zooms ahead and passes everybody. Um, and I don't think the driver could have seen this car coming at him. I think the Tesla identified the car, got out of the way, and then came back into the lane after the car, took off. So,
mm.
and there's
Wow.
nobody that's going to record that and report it, and this, somebody's life got saved, or it,
Mm,
it, it avoided a multiple call pileup, because of an accident. That doesn't get reported anywhere, right? So those
mm,
kind of things um, are happening,
mm.
and avoiding accidents, but you're not going to hear about them.
Well, I guess maybe Tesla can capture that stuff, can't it, with through their cameras,
That's
and
true.
they
Yeah,
can
yeah,
they could probably
yeah. They did.
promote that and promote that whole idea. Now, you were probably at CES recently. I was, not
Hmm.
CES, the convention center there, and they've got this Tesla loop, Vegas loop they call it, using
Yeah,
Tesla cars. I was surprised to see that there's no self-driving. It's all drivers. And
just for liability, probably, right? Yeah,
right, well,
yeah.
I thought to myself, if they can't do it in this closed environment where the thing's going down tunnels, how are they going to do it out in the wide world?
Mm. Well, I mean, I have a Tesla, and I turn it on to full self-driving to go, 100, 200 miles on the freeway.
Mm.
And for a freeway environment, and even during, a small town, it does really well.
All right, so let's explore some other areas. We talked a little about driving with sensor fusion and so on. Do you see it sort of vision systems going? I mean, this is kind of where we're going with this conversation. Do you see them going into other industries? I mean, I'm working in construction, for example. I see there's opportunities there. What are you seeing from your perspective?
Oh, absolutely. I mean, there's significant interest, and already there's autonomous driving dump trucks and large equipment. Um, there's quite a few cameras on farming equipment, right? To minimize. I noticed my video is kind of messing up, but there's cameras on farming equipment to reduce the amount of um, chemicals that get sprayed on crops, right? So
Mm,
analyze, look for weeds, and only spray if there's a weed, for example,
right.
right?
I saw
And
that.
I
It was a couple of years ago.
yeah.
We were at CES, and I think it
Hmm.
was I think it was John Deere
Yeah,
had
yeah.
a booth, and they these massive computers, and they were able to put exactly the right amount of insecticide or pesticide or herbicide down
Yeah,
against
yeah.
and around the specific. Uh,
Hmm.
and okay, so they were, okay, we think, well, that's labor saving, but it's also resource saving. So it's extremely good at metering out that particular insecticide or herbicide so that you really lower the amount that you need, but also you don't have this, this too much of it going out and getting in and I guess infecting the soil. So,
Exactly, yeah. And the drainage and whatever extra doesn't get, absorbed and processed by the plant doesn't get drained to to
mm,
rivers or to somewhere that in the water supply.
who would have
Uh,
thought that AI would have an environmental impact, which is positive?
I know, right? It's pretty cool.
It gets a lot of negative press, right, with all the data centers and the stuff that's going on.
Yeah, yeah, yeah. What do you think about the data center impact?
I think, yeah, I believe there's no choice. If we don't do this, we fall behind. Everybody is doing it. I guess it's a necessary challenge. I'm going to say evil. I think it's going to definitely impact our energy usage, but we have been on a trajectory since the Industrial Revolution, or even before that, of using more and more energy per capita, and I don't see that changing. I think if you
Hmm.
cast yourself into the future, the energy consumption of every single person is just going to continue to go up. So the challenge to me isn't to turn off data centers. The challenge is to find ways to better create energy and use it more efficiently. Look, I'm not going to turn off my use of AI. I'm not going to stop, jumping into Chat GPT, and I'm going to be more and more and more demanding on it. And
Hmm.
everybody I speak to on this podcast and pretty much who's active in business or in technology is using it more and more. So we're all in there, whether we like it or not. I don't know. What do you think, Chris?
Yeah, no, I mean the right now it's the integration is in servers and a lot of it's in tools that we use on a daily basis. And people are using it for code. Probably the biggest advantage is with coding, is people that are writing software. They get significantly more efficient by having AI tools help them write code.
Mm,
But I've seen the application in all kinds of areas at
mm,
work, right? And
mm,
whether it's from having you're trying to save multiple images from Outlook, and all the images have the same name because you transferred it from your phone. They all say image.jpg.
mm,
Copilot, for example, can generate a PowerShell that'll download those images, change the name for each one, so they don't overwrite each other, and just provide a solution. That this is an example of the kind of things that AI can help people do. And
mm, mm,
there's all kinds of examples like this where it's acting as a tool, but it's
mm,
but it's very directed, very specific requests,
mm,
um,
mm.
and it is like a calculator, right? It's like an advanced calculator that's helping you achieve what you want to achieve,
Yeah.
um, and it's making people more efficient.
Yeah, I think it is a tool. I think I made a
And
commitment
what it
this year
can
to use it much
crazy.
more than I had been in the past, and to commit to several hours, at least several hours a week, and that's paying off because I find the more I use it, the more value I can extract from it. The more tools I turn on, the more ways I think. I think in the past I would have probably spoke to more people about my ideas, whereas now I tend to speak more to the chat bots as a kind of
Hmm,
way to bounce ideas back and forward.
interesting.
I'm starting to wonder if I'm too reliant on it, or maybe I'm trusting it too much.
Hmm,
Um, I've just noticed my workflows have shifted,
okay.
away from what I used to do towards that. And it also builds up a history of you too. So it knows from your context, oh, you actually were talking about this over here. It was a completely different chat and incorporating that in. They're starting to know me. And I think that's extremely powerful. Yeah.
Right, and that's one of the things I'm interested in is the fact that this a lot of people that are developing this agent sort of in a wave or this chat GPT, learning about themselves and what they ask and what they're interested in. That's a lot of it's on servers, right? And
Mm. Mm.
really, I'm interested in the next wave of people having this capability on their own computer,
Mm.
separate from a server.
Mm.
So, the Peter Cooper agent that learns and anticipates what you want, and you teach it maybe your own ideas and your own direction and nuance, and that becomes yours, not what somebody else owns.
Right.
um, and
Mm.
that's this is an area where people are just starting to realize, hey, I'm helping develop this capability for the rest of the world, or for on a server. But how do I develop that capability so that I can own it, or if I want to move to a different source, or
Yep.
add some capability that it's mine. And
Yep. And keep it private as well. Yeah.
uh,
And also, I guess you have more scope to customize. So, I'm kind of
yeah.
limited with Chat GPT, for example, by the amount of memory it will allow me to take. I
Mm-hmm.
might say that I want you to take more memory. I'm
Yeah.
prepared to pay for that, and I want you to know everything about what's on my computers and everything I say.
Yeah.
And as long as it's all private, I want you to know me in depth and help
Mm-hmm.
me.
Mm-hmm.
As a very, very close partner. I think you've got a really good idea there. I think that's got some real potential.
Yeah, and then it's like you're developing your own children, and guiding, and as systems get more capable, you're developing those layers of constraint or context. Um, I just remember when, as an example, right, that my sister adopted a young boy, and the there's when you meet a child, there's a certain history and background that that you would expect from one environment that someone's been through, and then you meet a child that's been through a different environment, and you notice a difference, right?
Mm,
And so
mm,
that environment that a child grows up in, and what they learn, what they see, it significantly shapes who they are and how they process things, and
right.
the constraints around what they do and decisions they make. And I
Mm,
think AI is the same way, right? I mean, how we build the layers and how we develop that context
right.
becomes more and more important.
Yeah.
And that'll be more and more interesting as these systems get more powerful.
That's an interesting concept. I haven't wrangled with that one, but it's like the twins, the nature versus nurture, where twins are
Hmm.
separated at birth and they come back and they analyze, how
Hmm.
different they were based on the different environments. And I think the other thing is you're talking about boundaries. I think you mentioned that word boundaries. You can say, well, in every relationship, you can create boundaries, right?
Hmm.
I don't want you to call me outside of my work hours. I want you to call me during work hours. That's my time when I'll
Right.
deal with that. That's a boundary.
Hmm.
We could do the same thing with AI, right? We could say, well,
Yeah.
I want you to answer my emails, but only my
Hmm.
professional emails, not my personal emails, or something like
Yeah.
that. You could do a lot of
Right.
creativity around uh, building that AI model as a person, and then treating it as a person, and then creating all the relationship boundaries and the limitations and liberties that come with that. It's really
Hmm.
interesting.
Yeah.
Yeah. Well, Chris, we've covered a lot of really interesting ground. I want to switch back to the vision systems because that's where your expertise is. Where do you think this is going in the future?
Well, just like we were talking about the personal agents, the vision systems are adding these layers of um, you know ca- uh, causal reasoning, where they're they're linking the scene that they have uh, with prior history, and with
Hmm.
the physics of how fast is something moving. Where is it headed? Is it headed towards the car? And I remember a statistic looking at data in our county, for example, right? And 71% of the car accidents that resulted in death were related to lane departure changes, right? And it makes sense, because if you're departing lane, you're probably either going to hit a tree or hit an oncoming car, and head to head collisions are probably really dangerous. And this is one of the things that the AI systems are really good at, because they know where the lanes are. They know when a car is coming at them, where it's headed, and so it's the constraint of where they need to drive. This is something that AI systems is really good at. So I think there's definitely improvement in the death rate, right, of humans in cars in the future, as far as where they're headed. I think that's one thing, is that they're going to save a lot of lives.
So
And
go ahead.
well, we've seen from some of the OEMs that have analyzed the death rates of with cars that have their AI systems and cars that don't, right? And there's a definite improvement in the percentage of death rates. Anyway, you were
Interesting.
going to ask a question.
Yeah, no, I'd be interesting to see that, because I can see that somebody that's driving a Tesla's probably got a few other safety things that, so on and so on, whereas there's, maybe there's other factors, is what I'm saying, that aren't
Mhm.
just related to that. So I'd be very interested to see whether it's causation or correlation.
Yeah, it could be. That's true. I get your point.
But
But
it
yeah.
would be good to dig into that. I was going to give you one more sort of technical question. Do you think
Hmm.
there's a future in multispectral or multi-sensing? We talked a little bit about LiDAR in that sort of sense, but is there a future in not just a human vision system, but actually trying to see more of the spectrum, and then using that as part
That's
of the
interesting.
vision
Yeah.
system?
Some of our customers, they focused initially on, I want to analyze every single object, and so they focused on classification, and color was really important to them,
Mm,
reflectance, and they
mm,
built this huge database of 10,000 plus objects, and the one of the uh, reasons that they gave was, for example, if a water bottle flies off a car,
mm,
off a truck at you, do you slam on the brakes? Do you veer left and right? Is it going to kill somebody, or is it just a water bottle? And
mm,
I thought it was interesting, and a good first foray into what do you do with all this information.
mm,
um,
mm,
those systems, they're expensive. It takes a lot of processing power
mm,
to get that information. But for in general, that's where everybody started, right? And I think the object classification has, because the people have spent the last 5 to 10 years focusing on that, that is sort of a solved problem in a way, right? I think they're doing a really good job detecting what is this object.
mm,
The next harder thing is, the all the different decision making, and the next layer of, what do I do with this new scene that's happening, and
mm, mm.
um, that's kind of where everyone's focusing now.
Yeah, so knowing the material, multispectral can give you some understanding of the material that it is. So in your
Yeah,
example with the
right.
bottle, it's a plastic bottle, which is
Yeah.
empty, versus a
Hmm.
brick or a stone or something
Exactly.
that's a piece of pipe, which is
Yeah.
metal, and that could come right through the windshield. Right.
Hmm.
Yeah, that helps the decision making. Well, this has been a really good conversation, Chris. We're going to have you back, but before we finish, we have to give you the final question, which is
Okay.
AI, is it hype or help?
It's absolutely helping, um,
Hmm.
and the we're in the infancy, right? So,
Mm,
like most new technologies, there's a hype of people imaginations of like what the possibilities are, um, and those things will evolve. but it's not going to happen next year, or in 2 years, right?
Mm-hmm.
But we're things that people are imagining. Those were in Isaac Asimov robot books, right?
Mm.
Uh, you know, 20, 30 years ago, you could read about all this stuff and imagine what it could look like. 10 years from now, though, as the contextual relationships and the processing power that you can put in the size of a box for
Mm.
50 watts that doesn't drain an EV car battery, that'll be 10 times more powerful, and that 10 times more power is going to be adding this contextual interaction and the physics that you're talking about.
Mm.
And so that's when sort of new sort of capabilities are going to surprise people,
Yeah.
to the point where they trust it and they believe it's going to be safe, right? I'm
Yeah.
not sure everybody's there right now because of the corner case accidents and the things that happen. I'm not sure everybody trusts it, other than Waymo, which has significantly number of sensors and the processing power to avoid accidents. The trust is still developing. So, yeah, it's definitely a help.
Yeah. Definitely help. All right, Chris. Well, let's end on that. Thank you so
All
much.
right.
And
Thank
as I
you.
said, we're going to have to dig in again
All right.
to some more deeper topics. But
Yeah.
bye for now. Thanks.
All right. Thank you. Bye.
Wow, what a great discussion I had with Chris. We touched on some amazing topics. You might not know, or you may, that full self driving is becoming a reality. So, on the cars, we're seeing them now, and we understood a little bit of the challenges and how they've been overcome. Some cars have 12 cameras. They have very high dynamic range, which means they can literally see into the sunlight. But also the processing power that's required has become, affordable in terms of just the low wattage, so you can run it off, a car. And so, really fascinating. This is all emerging. It's going to happen very, very soon in the future. Chris also talked about some of his beliefs about where the LLMs are going, like ChatGPT, and he thinks there's a new frontier coming where we have more private chats and private information. And we talked about how that's going to evolve, the boundaries around that, and how useful that could be for us. And it's literally setting up a relationship with your AI. Agent on your own computer. Lots more stuff. Very interesting. Look, if you want to know more about Skillion, please click the links in the description. If you like this, please subscribe, hit the like button. I hope that helps, and thanks for watching.